So this is so this is module 5 with the title Wireless Network Communication. So let's begin. The following are the modules that's the module objectives, module title, module objective. So looking at the topic title, we have wireless communication, WLAN, that's WLAN threats, secure WLANs, that's secure WLAN. So these are the things we'll look at. So wireless communication is the one we begin with. So there is a video for you to watch. You need to take your time and watch that video. It also explain what relates to this module. So wireless communication, wireless versus wired LANs, that's local area networks. The table summarizes the difference between wireless and wired LANs. So when we say wireless, it means you're using radio signals to exchange data. And when you say wired, we are talking about copper cabling. It can be copper, it can be fiber, where you still exchange data between systems. Characteristics, that is the first column. The second column is the wireless LAN. The third, you have the wired Ethernet. And sometimes when you see this code on these values that is written 802.11, anytime you see that, we are talking about wireless communication. So it's a standard by IEEE. They came up with a standard for wireless and they named that standard 82.11 or 802.11. Then they also brought another standard for wired communication or for wired in LANs, which is also referred to as, that's based on the value, is 802.3. So whenever you see 802.3, we're talking about IEEE wired Ethernet LANs. So you only see a preceding letters, like for the wireless, you have IEEE 802.11 or IEEE 802.3. So physical layer. The physical layer for wireless, it uses what? Radio frequency, RF. The physical layer for the wired is usually physical cables. The media access. The media access, what we mean is the media are usually being shared. Not only the wireless device can access the radio frequency, you can have other devices that are accessing the same media. Same goes for your wired. You have, like in wired communication or the wired LANs, you have various devices that will share the same media. So that's what we mean by media access. So in the process of media access, there's what we refer to as collusion. In the process of trying to send data from one device to the other, at the same time, another device is trying to do the same, sending information or receiving the data. Since you're using the same media, you could have collusion. The same goes for wired. You can have collusion of data. But to prevent this collusion from happening, for wireless, we refer to it as collusion avoidance. Then for wired is called collusion detection. So the collusion avoidance is the system sense if no one is transmitting, okay, then a timeline is given or like a turn-by-turn process. If it's your turn, you now send. Okay. The collision detection is the moment there is a colliding data within that same media. Okay, then everyone is being positioned in a manner that's in a waiting manner. So that one too also happens like turn by turn. So if the first system sends, it waits till the first system completes sending before the second system also follows. So you have that's collision detection for wired. Availability, anyone with a wireless NIC in the range of an access point can gain access to this. Then for the wired or the LANs, physical cable connections are required. Signal interference, yes. For wireless, you have signal interference. You could have another RF signal that could interfere with the current signal you have. Then for wired, it is minimal. The interference are usually minimal, sometimes negligible. Regulation, different regulations by country. That's for wireless. Every country will have their own policy on how and what you need to do or what you need to put in place before you use wireless communication. IEEE for wired, the IEEE standard dictates how the communication is done, but for the wireless, they are being regulated by country policies. But for wired, that is not necessary. Okay. All right. Welcome, everyone. Udas Mubashir Mansur, Kutura, Jonathan, Olubenga, Evelyn, you're all welcome. So let's go back.
Thank you.
So still on wireless communication, 82.11 frame structure. You know, in the last class, we talked about something that's layer 3. We talked about packets. That's the PDU. Then the transport, we talked about segment. Okay. If you go down after 3, you go down to 2, you have, that's a layer 2, we have the frame. So in layer 2, what understands frames are usually what devices like switches, hubs, you hear things like that. When I talk about switches, these are devices that provide access. It's an intermediary device that provides access to host devices or to end devices. Okay, that's intermediary device. Then you also have another type of intermediary device that operate at the level of layer 3, which are usually called routers. So routers operate that at that level. So routers understand what we refer to as packets, the forward packets. Then switches understand that's the type of data switches understands are called frame. So a frame has a structure. Just like when we looked at the IP version 4 and IP version 6 header, it has a structure. The same goes for frame. Frame has its own kind of structure. All layer 2 frames consist of a header, payload, and frame check sequence section. The 82.11 frame format is like the Ethernet frame format, except that it contains more fields. So what do we mean by some of those fields? We'll look at a picture that provides a structure for a frame. So well, let's look at each of those areas within the frame structure. So we have the first one, the frame control. It identifies the type of wireless frame. It identifies the type of wireless frame and contains subfields for protocol versions. Frame type, address type, power management and security settings, that is frame control. Then duration, it is typically used to indicate the remaining duration needed to receive the next frame transmission. You know, the frames are you don't have and that's like you have multiple or sequence of frames. So each frame, as they are being transmitted over the link or the network, one is being sent, another one follows. So there's always a duration for when the next frame should be transmitted. Address 1 is usually contains the MAC address of the receiving wireless device or access point. If you could recall, we talked about physical address yesterday. The physical address is also your MAC address, which is also, that's when we look at it in a natural way, the MAC address can be referred to as your fingerprint. The packets or IP address can be referred to as your envelope, your mail that you send from one location to the other. And I said the MAC address doesn't change. If you move your system from one network to the other, it still remains, which can be referred to as your fingerprint. But your IP address changes as you move from one network to the other. So you have a address 1, what is attached to the frame structure. That's the address 1. It usually contains the MAC address of the receiving wireless device or access point. Then we have another address 2. It usually contains the MAC address of the transmitting wireless device or access point. So even that yesterday when I did ipconfig/all, we saw that of my wireless device, which is the NIC. Okay, it provides the MAC address for my network interface card. The wire too has its own, but our focus today is on the wireless communication. Address 3, it sometimes contains the destination MAC address, such as the default gateway. So default gateway to which the access point is attached, that is address 3. So when we say default gateway, a way out of the network, a way that's the main gate that takes you out of the network or takes the data out of the network, and also is the gateway where other data come into your local area network. Sequence control, it contains information to control sequencing and fragmented frames. So the fragmented frames, you have them in sequence. They are being numbered, special numbering that are being attached to each of them, which are unique, such that before transmission, you have the fragment. After the transmission, that's at the receiving end, these fragments are being brought together to assemble together to form a complete information. So that assembling is based on the sequencing value attached to each frame. Address 4, it is usually missing because it is used only in ad hoc mode. So it means within the network, you can have an ad hoc kind of services for wireless communication. Payload, it contains the data for transmission. This same payload is the one that contains, when we talked about encapsulation, that encapsulation. So for you to encapsulate a packet to form a frame, that packet you've encapsulated, that is your payload. So the packet also encapsulates what? The segment. That segment also is your data that contains in it. Even within the segment, it encapsulated the data. So you have this kind of encapsulation process as you move down the ladder when you're talking about the OSI model. So the payload, it contains the data for transmission. Then FCS, it is used for layer 2 error control. This is just to check that the frame has not changed. It's just to maintain the integrity of the frame when it has been transmitted and received. So the one, CSMA CA. So you come across this often when you're dealing with wireless communication. So CSMA CA, the CA stands for collision avoidance. Okay, so WLAN are half duplex, shared media configuration. What do we mean by half duplex? Let's use a simple walkie-talkie. A walkie-talkie, let's say I'm communicating to Edgar. Edgar has a walkie-talkie. I have a walkie-talkie. And how does it operate? When I speak, Edgar listens to me. When I'm done speaking, I keep quiet. Edgar speaks. Okay, so that's what we mean by half duplex. Both of us cannot speak at the same time. If we speak at the same time, we'll have an interruption. We won't be able to understand ourselves. So that is what we mean by half duplex. So shared media, it means when you are dealing with wireless communication now, every device that communicates to maybe you see an SSID. We'll talk about the SSID later on. The SSID, let's say, is IT Essentials. Edgar is connecting to IT Essentials. I am connecting to IT Essentials. And any other member of this class is connecting to the same IT Essentials. So, but in terms of this communication, all of us cannot be speaking, all of us cannot be communicating at the same time. Okay, and even the access point, when the access point is, like, let's say for myself, I'm communicating to the access point. When I'm sending, the access point listens to me. And once I'm done, the access point sends. I will now listen to the access point. So that is what we mean by half duplex. So when we say shared media configuration, okay, Edgar is also part of that same shared media. Other members of this class are also part of that shared media. So we're looking at the wireless communication. This creates a problem because a wireless client cannot hear while it is sending, which makes it impossible to detect a collision. So to resolve this problem, wireless LAN use CSMA CA as the method to determine how and when to send data on the network. A wireless client does the following. So we're talking about a wireless client. You have a wireless client, and who is the wireless client? Your laptop or your mobile device. And your mobile device is connecting to an access point. So what happened? So listen to that's the first listen. Listen to the channel carrier. That's a wireless client does the following. Listen to the channel carrier. That's the channel carrier to see if it sends, we're talking about the shared media now, to see if it senses no other traffic on the channel. That's the channel is idle. For the communication, for me to send something over across, I have to be sure that the channel is idle. Then send a ready to send. That sends a ready to send message to the access point. So after I've observed that the channel is idle, I will now send a message, which is called the RTS, message to the access point, to request dedicated access to the network. So it means when I send the message, the access point is now, it clears the ground, ready for communication to begin between my client system, which is my laptop or my mobile phone, to the access point. So after that, the access point does something, receives a, okay, uh, sends a ready to send RTS message to the access point to request dedicated access to the network, receives a clear to send message from the access point granting access to the send. So what we mean now, the access point now respond back to the client. They respond back to the client with a message called the CTS. So the client now get the CTS that everything is clear for him to now make the communication. So if the wireless client does not receive the CTS, so if the wireless device does not receive the CTS message from the access point, it waits again for a random amount of time to restart the process. So it waits. So what it means is that if it doesn't receive it, it means probably another device is already sending a message. So that's another device has sent a message and the access point has given a clear ground for communication to take place between the other device and the access point. So you have to wait, okay? the initial device have to wait. So if the wireless client does not receive a CTS, it waits a random amount of time to restart the process. After it receives the CTS, it transmits the data. So by the time it finally gets the CTS, that is when the client now sends the data. All transmissions are acknowledged. If a wireless client does not receive an acknowledgement, it assumes a collision occurred and restarts the process again. So if there's no acknowledgement, so at every send, as any moment the client sends a message, he always gets an acknowledgement. So once it gets it, it means it can proceed to the next stage. So wireless client and access point association. For wireless devices to communicate over a network, they must first associate with an access point or wireless router. When we say wireless router, a good example of wireless router is those ones you know, like the SIM router, MTN SIM router, Airtel SIM router. All those ones are also access point. It performs multiple functions, but our focus now is just the access point. So, but when we say, okay, in addition, when we say wireless router, it performs the function of a router. It performs the function of an access point. Okay. It also, some of them perform the function of a switch. They also have other features that they do. So an important part of 82.11 process is discovering a wireless LAN and subsequently connecting to it. So you open up your device, you want to connect to a wireless network. What do? You open up your Wi-Fi, you now see options, you see the various devices that are available within that location. So wireless devices complete the following 3 stages. That's stage process. So these are the stage process in terms of trying to connect to an access point. The first one, once you power on your Wi-Fi, you search, okay? That stage, at that stage is discover a wireless access point. That's the first stage. The second stage is authenticate with the access point, meaning once you discover it, you see IT Essential Network. You connect to it, you are now asked to input what? Passwords. Then after that, you now have associate with the access point. That's after the authentication is everything goes fine, then association now takes place. So these are the 3 stages in terms of how these clients connect to access point. So a wireless client and access point must agree on specific perimeters that must be configured on the access point and subsequently on the client to enable the negotiation of a successful association. What are those things that you need to, what are those parameters that are required? SSID, the SSID, IT Essential Network, that's an SSID. You open up your Wi-Fi, you now see various names of an access point. Those are called the SSID. So it appears a list of wireless network on a client. So password, it is required from the wireless client to authenticate to the access point. It therefore means that for you to connect to that access point, you must have the password. Network mode, it refers to 82.11a, b, and AC, AD wireless standard. This is a standard. The earlier access point and that's the earlier access point or wireless LAN have this standard. It started with the A, it started with B, it started with G, started with ends with N, moves to N, followed by AC, then AD. So the current ones that you have the network mode are usually the N, AC, and AD. So looking at all this, it's referred to the speed. I believe you heard things. People are working on it to come up with 6G. So if you look at all these generations, these are generations. The generations, you see it has improved in terms of speed, in terms of security. The same goes with this 82.11. It's from A, B, G, and AC. Improvement in terms of security, web, WPA, WPA2. We're going to look at this later. Channel settings. It refers to the frequency bands used to transmit wireless data. What we mean here is channel band. Sometimes you can have more, but you may have interference if their frequency are on the same channel. So what you need to do within these settings is to separate channel. Let's assume you own the access point. You put one on a different channel, the next on it, like that. So you create a separation so that you don't have interference. We'll come to that later more. So let's look at the passive and active discover. Wireless device must discover and connect to access point or water. Access point using scanning, probing, recover. You have to probe. Put your mic on mute. I think this should be Ajayi. Ajayi, we're getting an interference from you. Yes, thank you.
Yes, I'm sorry, please.
No problem, no problem. So, so in the process of discovering, we call it probing. One of the probing, that's to scan, to try to get the available access points. So wireless client connect to access point using scanning probing process. This process can be passive or active. Point at its service frames containing the SSID, supported standard and security settings. So in this case, periodically, there's a beacon that is being sent. This contains what? SSID, that's IT essential, supported standard, the standard that are required to put everything in place, security settings and whatnot. So these are the beacons that are being sent, okay? So that is passive. Then active mode, while class hold the name of the SSID and initiate process by broadcasting a probe request frame on multiple channels. What we mean here is that in this case, you don't have probes. So for you to connect to the access point, it means you must know the name of the access point. So that access point, the SSID has been disabled. So you don't see the name. That's when you put your Wi-Fi on, you don't see the name of the access point. So what it means, you need to do it manual. You need to enter the name of the access point. That's if you know it, let's assume it's the same IT essentials with respect to that with the uppercase, lowercase observed. Let's assume IT in caps, okay? The essentials in small letters or lowercase. So that's how you have to enter that using the active mode. You have to enter it on your client, then for your client to begin to associate itself with the access point. So access point configured with the SSID will send a probe. So by the time you configure the SSID on the client, the access point configured with the SSID will send a probe response that includes the SSID supported standard and security settings. That's after you are able to do the first stage. Then the next stage, this association now takes place. The SSID, the access point send the SSID information, supported standard and security settings. Wireless devices, access points, LWAP, and WLC. Let's look at them. What do they mean? Home and small business wireless router integrates the functions of a router, switch, and access point into one device. That's the one I've mentioned before. Like your SIM router is a good example of that. The one you have at home, SIM router, performs the function of what? The router, switch, and access point. So all the control and management function of an access point on a network can be centralized into a wireless LAN controller. So what we mean here is you can have, let's assume the access point have a limitation in terms of coverage range at which you can send the signal. So when we say a limitation, so what you need to do is to have multiple of this access point, maybe stationed in various locations. So that as one moves from one location to the other, the person that's out of the range of the first access point into another one, the person should be able to connect to the new network. I mean, to the same network. So, but for you to be able to manage this large number of access points, maybe scattered all over the campus, you need what we call the wireless LAN controller. So it's a controller that allows you to monitor, to manage all the various access points within your campus. So when using a WLC, the access point no longer act autonomously, but instead act as lightweight access point. What we mean is that in this case, the access point will that's when you have the access point, it doesn't work alone, and it doesn't carry other functions like the functions of switch or router. It doesn't carry other function. So its own is to focus on just forwarding data. Okay, it's just to forward or to act as an access point. That is just the function. It doesn't carry the issues of a router, a switch. No, it doesn't carry this one. So its own focus is just the function of acting as an access point. That's all. So LW or LWAPs only forward data between wireless LAN and the WLC. That's a controller. So the wireless LAN, that's a connection between devices to the WLC. That's what it does. So that's the LWAPs or LWAPs. A major benefit of centralizing the access point management function in the WLC is simplified configuration and monitoring of numerous access points. So the beauty about this is that you can do a lot of things. You can monitor activities based on a particular access point in a location. Like here, we have the IT guys in the University of Jos. You have some IT guys. What they do is that they have this access point scattered all over some location within the campus, and the admin, that's the IT admin, who is located within the control station, and from that place he monitors even the data usage for each of the access point in different locations. And also he can decide to disable a particular access point in a location. So there are many things you can do with WLC to manage various access points. So let's look at wireless threats. That's wireless LAN threats. So there's a video for you also on this. So wireless security overview. With a wireless NIC and knowledge of cracking techniques, an attacker may not have to physically enter the workplace to gain access to a wireless LAN. So, like in the case of a wired network, a bank facility, they have their own local area, or within your own organization, you have a local area network. So for anyone to gain access, or to gain access, probably to steal information or to destroy or do whatever kind of malicious intent, the person have to gain access to the facility, gain access to where a router or a switch or is located, and plug his device. That is when you are dealing with the wired kind of communication, the wired LAN or the local area network. So, but when you are dealing with this wireless LAN, it's different. It's different. So it's not necessarily the person must be within the building. Even the person is outside the building, as long as he's able to gain access or he sees the communication, he's seeing the signal network. So wireless network, it doesn't mean you have to be inside the building. The person can be outside the building to begin their attack. So wireless network are specifically susceptible to several threats, including what? Interception of data. Wireless data should be encrypted to prevent it from being read by eavesdropping, okay? So interception, that's just you intercept the data and you read the content of that data. So wireless intruders, unauthorized users attempting to access network resources that can be deterred through effective authentication techniques. So denial of service is another one. Access to wireless LAN services can be compromised either accidentally or maliciously. When we say accidentally, maybe accidentally by mistake, in the configuration, something was disabled and the access point cannot be accessed, or maliciously, the attacker is able to gain entry and is able to disable the access point. Then rogue access point, I think we mentioned the unauthorized access points installed by a well-intentioned user or for malicious purpose can be the software. So like for this rogue, you have IT Essentials. You see the access point, then you see another IT Essentials with the same name. Then the next, probably you connect to rogue because the signal strength is good. So these are wireless network susceptible to several threats. So DOS attacks. Wireless DOS attacks can be the result of improperly configured device. So why you end up with this kind of attack is either you have improperly configured device. Configuration error can disable the wireless LAN, so that can form the DOS attacks. A malicious user intentionally interfering with the wireless communication, their goal is to disable the wireless network completely or to point where no legitimate device can access the medium. That's also part of a DOS attack. Accidental interference. Maybe you can also have, aside accidental interference, you can also have signal jammers. Signal jammers that it falls within the frequency of an access point so that it cancels the frequency, of the radio frequency. It cancels it out. So that can also be another form of attack, which is not mentioned here. But accidental interference, you can have other devices that is operating at the same level of the access point in terms of the frequency. And usually what are common things that operate at that level that can be of interference are what? Micro ovens, cordless phones, baby monitors. They operate at which frequency? The 2.5 gigahertz is more prone to interference than the 5 gigahertz. So most of the wireless devices operate within this frequency, the 2.4 and 5 gigahertz. But for those cordless phones are common with the 2.4. To minimize the risk of DOS attack due to improperly configured devices and malicious attack, harden all devices, keep passwords secure, create backups, and ensure that all configuration changes are incorporated off hours. So when we say harden, it's more of like building more security policies into your device. Rogue access point. A rogue AP is an AP or wireless router that has been connected to a corporate network without explicit authorization and against corporate policy. Anyone with access to the premises can install an inexpensive wireless router that can potentially allow access to a secure network resource. So the connected rogue AP can be used by an attacker to capture MAC address, capture data packets, and gain access to network resources or launch a man-in-the-middle attack. So a personal network hotspot could also be used as a rogue. So you can also use your phone as a rogue, whereby you create a name, you put a name that is similar to an already existing SSID. So to prevent the installation of rogue access point, organization must configure their WLC with rogue AP policies and use monitoring software to actively monitor the radio spectrum for unauthorized access point. Man in the middle. So man in the middle, the hacker is positioned in between two legitimate entities to read or modify the data in the two parties. So evil twin attack. An attacker introduces a rogue AP and configures it with the same access ID as legitimate AP. Wireless client attempting to connect to a WLAN, see two access point offering wireless access. Those near the rogue access point find the stronger signals and most likely associate with it. User traffic is now sent to the rogue access point that captures the data and forwards it to the legitimate access point. Return traffic from the legitimate access point is sent to the rogue access point, capture and forward to the unsuspecting user. So this is using the rogue. So let's see. After this, I'm going to do a little bit of demo again with respect to wireless access point. So you still have some labs that you need to also would do, which I'm going to send across. Then in terms of submitting the assignment, just like I said, on Saturday, I will send a message. I'll let you know where you can submit the assignment given to you so far. Secure wireless LAN. So let me pause a bit before we move. So far, any question from you from what I've just presented this evening? Any question, Edgar, Odas, Mubashir, Kutura, Ajayi, Bello, Aminu, and Tohit?
No question, sir.
You have a question, Bello? Go ahead.
No question, sir. No question, sir.
Yes.
Okay, I thought you have a question. Gideon. How about you, Gideon? No question from you. Edgar?
It's Edgar, sir.
Okay, so let's proceed. So I believe you still have my slide. If you do, just say yes.
Yes, sir.
All right.
Yes,
Thank
yes.
you. Okay. So let's proceed. Let's move to the next one, video. SSID clocking and MAC address filtering. So how do you secure your access points? How do you secure that? That is what we want to look at. Or either your access point or your SIM router, whether it's SIM router or wireless router, whichever. So that's what we want to look at. So for the SSID, to address the threats of keeping wireless intruders out and protecting data, two early security features. I think I'm getting an interference. Edgar, can you put your mic on mute, please? Okay, thank you. All right. So let's proceed. To address the threat of keeping wireless intruders out and protecting data, two early security features were used and are still available on most routers and access points. So SSID clocking and MAC address filtering. So let's look at the first one, SSID clocking. Access point and some wireless router allow SSID beacon frame to be disabled. So like when we are talking about the active mode, you try to hide. You don't want anyone to see the SSID. You disable that. So when you disable that, it means anyone that power the Wi-Fi or Wi-Fi device will not be able to scan to find out which available access point that is up. So wireless client must manually configure the SSID to connect to the network. So it therefore means that the client or your system, you have to know the SSID of the access point that is not being broadcasted. So what you need to do is that once you have it, you manually find a way to, there's a place for you on your PC to enter or your device. MAC address filtering. Another way you can protect intruders from connecting to your wireless device or access point is by using MAC address. What does it do? An administrator can manually permit or deny access to address MAC hardware addresses. So what it means is whoever that wants to connect to your network, you must first of all, within the device, you enter the MAC address, and there's a place that you can add as deny. You see that when you say deny the MAC address, so if that particular individual wants to connect to the wireless access point, he's denied access to that device. Then there's another one that allows you to permit or allow. So when you permit the individual, it means the individual will be able to gain access to the access point. We're going to look at this later. In the figure, the router is configured to permit 2 MAC addresses. Devices with different MAC addresses will not be able to join the 2.4 gigahertz wireless LAN. So like in this case, just two devices were permitted. So if you're not permitted to gain access to the network, any other device will not be allowed, will be denied access. So once you allow just 2, so there are various ways you can configure. Another way again you can say two MAC addresses. When you deny 2 MAC addresses, any other person aside connecting to that access point will have access, while the other 2 that you put in deny will be denied. Probably it could be a rogue access point or another system, unwanted system that we have noticed over time. So we want to prevent that system from gaining access to our network. So 82.11 original authentication methods. SSID are easily discovered even if access point do not broadcast them, and MAC address can be spoofed. So even so, you can see how no matter what you do, the threat actors will always look for a way, will look for vulnerabilities, will look for weakness around the device. So if when you do to you disable that, they still find their way. Even you spoofed, sometimes when you say, okay, you only pick the MAC address of some certain systems that you permit them access, an attacker can still also spoof one of the MAC address. So even the spoof, then it means they can still gain access. So the best way to secure a wireless network is to use authentication and encryption systems. Authentication and type with the to join, everyone to connect. Open system, any wireless client can easily connect and should only be used when security is of no concern. So in this case, let's say at home, you have yourself, other family members, you trust them, you have no issues. So you can make it open. You don't need to say for anyone to connect, they need to enter password. So that you're sure that you won't have any security issues. Then the shared key authentication. Provide a mechanism for web, WPA, WPA2, and WPA3 to authenticate and encrypt data between a wireless client and access point. So these are different authentication mechanisms that can be deployed, or you can select when you're configuring an access point. So that is it for this part. Let's move to the next one. So in this now, I want to look at deeper on these different authentication methods. So shared key authentication methods. When we say shared key, there are 4 shared key authentication techniques available until the availability of WP3 device become anyway, let me ignore this. Finding it difficult to pronounce this. Wireless network should use the WPA2 standard. So what we want to say here is that when we say shared key, it means the access point will have the same key, okay? The client will have the same key for communication, that's for authentication to take place, okay? So let's look at the first one, the web, wired equivalent privacy. Wired equivalent privacy. The original 82.11 specification designed to secure the data using reverse cipher 4, RC4 encryption method with a static key. However, the key never changes when exchanging packets. This makes it easy to hack. Web is no longer recommended and should never be used. So what we mean here is that when you enter like a password, that is your key. You enter it like a password, the password. So the every packet that moves from one point to the other, it goes with that information. So that information or the password or the key that you enter, not really the password, but the key, sorry, the key that was used will not change. The key remains the same. So for each packet that flows from one point to the other, one packet moves is the same key, the next packet moves is the same key. That is web. So this particular authentication method is not secure. The next one, Wi-Fi protected access. A Wi-Fi Alliance standard that uses web but secures the data with a much stronger temporal key integrity protocol, TKIP encryption algorithm. So TKIP changes the key for each packet, making it much more difficult. So for every packet that flows within that network, a new key is given, a new key. So it's not the same key. So that's the reason why web is a lot easier to crack. If you're using a network access point, you configure your access point to use web, is a lot easier to crack or is a lot easier to hack. But if you use this one is a little bit difficult for any hacking to take place. WPA2. WPA2 is the current industry standard for securing wireless network. It uses advanced encryption standard. A is for encryption. ACE is currently considered the strongest encryption protocol. So this guy is much more stronger than the TKIP, okay? It's much more stronger. So that is what most of our devices are using currently today to authenticate the access point and the client. Then there's a new generation, which is the next generation, WPA3, the next generation of Wi-Fi security. WPA3 enabled devices use the latest security method, disallow outdated legacy protocols. So outdated legacy old protocols that we no longer see them important in our network. We disallow this particular WPA3 disallow such and requires the use of protected management frames, PMF. However, devices with WPA3 are not yet readily available. These ones are not available for now, but most of the systems we use today use WPA2. So this is much more advanced, the WPA3, in terms of authentication. So authenticating a home user. So when we say home, a user at home who has a router. So a home router typically have 2 choices for authentication. So when you're using a home router, whether your SIM router or whatever, some of them may have provisions to allow you to select between these 2. But some, you may only see just the WPA2. So, but WPA2 is always recommended. It's much more stronger, better than WPA. So 2 WPA2 authentication methods are personal. So if you're using this at home and you want anyone that wants to gain access to the network to use to authenticate, you can use this simple one, which is personal, intended for home or small office. Users authenticate using a pre-shared key. So that pre-shared key, it means the access point has been configured with a password, okay? And whoever that wants to gain access to that access point or wants to connect to the access point must have the same password and enter that into the client's device. So that's what we mean by pre-shared key, PS key. So wireless client authenticates with the wireless router using a pre-shared password, okay? So that's I'm interchanging the words, it's still the same. So enterprise, in this case, when you have another option, that's for personal, is for your personal use. And in this, I think one of the lab we're going to do, you're going to choose this particular one. Then the other one, which is enterprise, for a larger network, enterprise network, intended for enterprise network, but requires a remote authentication, dial-in user service, radios, authentication server. So in this case, it means you have a radio server somewhere within your network. Its own duty is to keep information regarding to authentication. So instead of having it directly on the device, everything is kept or housed within the radio server. So the device must be authenticated by the radio server, and the user must authenticate using 82.11.1x standard extensible authentication protocol. So this is another method in terms of how a client can gain access to the wireless network. So there's a process between the client and the access point. It uses a standard which is called the 82.1x. But between the client and the server, it uses the radios. Okay. So it is not just a kind of straight kind of connection between the client and the server. The client communicates to the access point or the wireless router. From the wireless router, it connects to the radio server. So encryption methods. WPA and WP2 standard use the following encryption protocols. So temporal key integrity protocol, TKIP. It is used by WPA and provides support for legacy wireless LAN equipment by addressing the original flaws associated with web encryption. But the one that is better is the advanced encryption standard. It is used by WP2 and preferred method because it is a far stronger method of encryption. So it uses counter cipher mode with block chaining message authentication code protocol, CCNP, that allows destination host to recognize if the encrypted and non-encrypted bits have been altered. This one is just to check for integrity of the data. So let's go to authentication in enterprise using the radios. So in networks that have stricter security requirement, an additional authentication or login is required to grant wireless clients such access. The enterprise security mode choice required authentication, authorization, and accounting. So what we mean in this kind of authentication process is that the beauty about this is that when you authenticate, okay, in terms of authenticating, first of all, authentication process is who you are, tries to identify who you are. Who are you? Okay, that is that. So that's authentication, tries to identify who you are. Then authorization, once you have been identified who you are, then the system authorizes that very individual. So if you are legit, it authorizes you. That's what we mean by authorization. After who you are, identify whether you are a part of the organization. If you are part of the organization, you have the license to work in that organization, then you are authorized to come in. Then the final one, whatever you do, at the time you log in, or at the time you are authorized to log in, and at the time you log out, everything is being kept in a file. That's logs. The logs about what you did, how you went out, how you came in, what processes you did. So that is accounting. So the system keeps accounting of your logs. That's it, keeps information with respect to your logs. So radio server's IP address. The radio server's IP address, the reachable address of radio servers. So every radio server will have an IP address such that it can be accessed. So within the, when it comes to configuration, which is also part of the work you're going to do, there's a place for you where you see the server, where you can input the server address. So in your access point, you need to tell the access point where the radio server is. What is the IP address of that server? That is it on this. So what you see here, the picture is a picture of a wireless router or an access point. But please, it's better we use the word wireless router such that the wireless router performs the function of a router, switch, and access point. So this is a wireless, a wireless router. So in the wireless router, still on the authentication in the enterprise, you have UDP ports, user datagram protocol. Officially assigned UDP port 1812 or 1812 for radius authentication and 1813 for radius accounting, but can also operate using UDP ports 1645 and 1646. So this one is, when we talked about the transport layer, we talked about maintaining conversation. Different, you have so many kind of conversation that happen within, but you have a port number that is allocated for a particular conversation. So within this, you can now select and say, okay, if I'm to use port 1812, it means it's meant for authentication. Anything that has to do with authentication, we use this port. Then anything that is used for accounting, we use this port, and so on. So shared key used to authenticate the access point with the radius. Access point with the radius, that is the shared key. So you have a place where you need to enter the shared key. So just like I said, it's not for client, please. It's between the access point and the radio server. So this is just about the WP3, which is the latest, but it's not available within, it's not yet available, but that is the future. So at the time of this writing, devices that support WP3 authentication were not readily available. However, WPA2 is no longer considered secure. So you can see every day we're advancing. Hackers are devising various means to gain entry or gain access. So things are changing. So as hackers are making moves, also, we need to also find a way to make move to protect other users on the network. So WPA3 is available, is the recommended 82.11 authentication method. So WPA3 includes the 4 features. So it also has personal, enterprise, open network, that's to allow anyone to connect to it, and also Internet of Things onboarding. So it makes provision for Internet of Things, connecting various devices to the network, anything you can think of onto the network. So there is a packet tracer for you, which you're going to do. There's a lot of packet tracer in this chapter. So as it is, we have come to the end of this very slides, which is the module 5. So while I wait for you guys to ask your question, let me start up the other system so that we can go to it and just do a little bit of demo before we end today's class. That's after you guys are able to ask your question. So any questions so far with respect to this? Edgar Udas. Kutura, Ajayi, Bello, Aminu, Tohit, Jonathan.
No question, sir.
Gideon.
No question.
Is it no question from you?
No question,
Wow, it
sir.
means you guys are ready for this course then. If there's no question, I think we
Yes, sir.
don't need to proceed. We just move to the next what do you call it? Maybe we just move to the next course. Or what do you think? Huh? So okay, let me quickly start the other system. Let's see so that I can just do a little bit of demo. And when it comes to your labs, that won't be difficult for you. Okay, let me set up. Sorry. Okay. So let me pause this.